Ladies and gentlemen, on behalf of the Northwest University, thank you for joining us on this day 2 of the Faculty of Natural and Agricultural Sciences of the Northwest University, where we focus on our postgraduate product offering. Today we're going to focus on physics and chemistry-based programs. Ladies and gentlemen, we are now going to look at the School for Physical and Chemical Sciences, and we're going to focus quite a bit on chemistry and biochemistry. Let's first start with a bit of a background on the school, and we're going to ask Derek van der Westhuizen to give us a bit of a background there. Derek, tell us a little bit about your school.
Thank you, GP. So in the Faculty of Natural and Agricultural Sciences, the School of Physical and Chemical Sciences expertise is divided into 3 subject groups, namely biochemistry, physics, and chemistry. And today we're going to talk about chemistry and biochemistry.
Thank you, Derek. Yes, let's focus a little bit on chemistry and biochemistry. Let's start with chemistry. So in the postgraduate environment, we basically start with the honors degrees and then masters and PhDs. Tell us a little bit more about the BSc honors that you have on offer.
So the chemistry subject group administrates the honors in chemistry, and any student who has chemistry in their 3rd year as main subject can apply to continue their studies with a BSc honors degree in chemistry. And that will feed into our research program for the MSc and PhD studies. Now today, I'm only going to talk about the BSc honors because at Potchefstroom campus, our MSc and PhD studies is handled with a focus area called chemical resource beneficiation within the same session. And then on Mafeking campus, Dr. Zimbili will talk about the MSc and PhD studies that falls within the School of Physical and Chemical Sciences.
Thank you, Derek. All right, so tell us a little bit about the structure of the honors program in chemistry.
The BSc honors program in chemistry composed of 4 compulsory 16-credit block modules in which advanced aspects like physical, inorganic, organic, and analytical chemistry are treated. Now, these 4 modules are presented in the 1st semester, and we call them block modules because they are presented in series. So for 5 weeks, the students will have a block module, for instance, inorganic chemistry, and at the end of the block module, there's an exam, and the week thereafter, the next block module starts. So what I also want to like to say is this compulsory block modules is aligned over the 2 campuses between Potchefstroom and Mafeking. And then furthermore, because in this program, we would like to prepare the students for a research-directed career. And by that reason, we're making use of specialist choice modules called Capita Selectas. And so that's the one part. The other part is there's also a project that should be completed during the course of the year. Now, let's talk first about the Capita Selectas. The 8-credit Capita Selecta modules are specialized themes supporting the research done in the subject group chemistry. They serve as an introduction to these themes, and they're also presented after each other, like the same as that we're doing for the block modules. And the duration for that is 1 week for each. So there's 4 of them, and there's about 15 choices for the students to take. Because this is specialized themes, some are only presented on the Mafeking campus, while others are presented on Potchefstroom campus due to the expertise on the different campuses. Then in terms of the project is presented as a 32-credit module, and that deals with research methodology and all other aspects regarding research in chemistry. And the aim actually for this mini project that comprises over the year is to familiarize the students with research process typically followed in chemistry. This research project is then done we not only deal with experimental aspects, but we also include other activities like scientific communication, where we equip students with tools to communicate in science later in their careers. The minimum duration of studies for BSc Honours in Chemistry is 1 year full-time. And unfortunately, we do not offer part-time studies because of the on-campus activities that students continuously are active in the labs, etc. So it's also important to note that the maximum allowable duration is only 2 years. So the students that take BSc Honours in Chemistry should finish within 2 years after they start their studies.
Derek, it sounds fascinating. I love the idea of a capita selector. There's always a relevance and a focus that comes along with it. And it sounds as if you really cover a very extensive field at the honours level when it comes to chemistry. Admission and application, if you could expand on that a little bit.
So admissions to this Honours in Chemistry program takes place by selection. To be allowed into the honours program, you must have first a degree in chemistry as a major, and this is usually a BSc degree. Now we have a limited laboratory space on the moment for our honours students, both on Potchefstroom and Mafeking campus, and for that reason, a selection process is in place. This selection process is based mainly on average mark that the students obtain for the second and third year chemistry modules. And then students with an average above 50% will be considered by the selection panel.
And Derek, what about the application dates?
So I can tell that students that are interested in BSc Honours in Chemistry are welcome to contact me for any queries relating the Potchefstroom campus and Prof. Fahimi for the Mafeking campus. And then for all general queries, they can contact Dr. Justice Roche, our subject group leader in chemistry. I can tell all applications for next year are done online and already open, and it closes by the 31st of October.
Thank you so much, Derek. Really appreciate it. That, ladies and gentlemen, on the honours in chemistry. But then you've heard there's also a master's and a doctorate on offer in chemistry at our Mahikeng campus. And now I'm going to ask Dr. Zimbile Mkhize to explain a little bit more about what's happening when it comes to the master's and the PhD in chemistry at the Mahikeng campus. Zimbile, thank you so much.
Thank you. The chemistry department at the Mafeking campus offers the Master of Science in Chemistry and the Doctor of Philosophy in Science with Chemistry. And to gain admission in the master's qualification, a student must have obtained an honors degree in chemistry, and to gain admission to the doctoral qualification, a student must have obtained the Master of Science degree in chemistry.
Thank you, Zimbile. Now tell us a little bit more about the experts that you have and the team, the people at hand that can provide postgraduate supervision.
The areas of research in the department are nano and other material design and application in various fields. The fields being medicine, agriculture, water treatment, toxic pollutants removal, catalysis, energy, electrochemistry, and corrosion inhibition. And there is also established research in areas of ionic liquid, deep eutectic solvents, thermodynamics, organic chemistry, both practical and theoretical, meaning computational, with the focus on drug discovery for treatment of various non-communicable diseases.
It sounds like you really cover the whole spectrum there in terms of chemistry. It's wonderful. So if someone is interested, is it a full-time study? Is it a 2-year or 3-year thing, or does it depend on the qualification?
It's full-time or part-time, and the maximum duration for a master's, if it's full-time, it's 2 years, and for part-time studies, it's 3 years, and the maximum duration for a PhD is 4 years. Both qualifications research-based, and they are structured for an MSc is a dissertation, and for a PhD is a thesis.
Thank you so much. Are you accepting applications now? How should they apply?
Yes, the applications are open for 2022, and they are handled by the group leader, the subject group leader here, and the school director. And it is always advisable for potential candidates to approach the proposed supervisors first for guidance before applying. And then the details of all the chemistry stuff are available on the website.
Website, right. Thank you so much, Zimbile. Now you've heard it, ladies and gentlemen. If you're interested in doing your M or D at the Mahikeng campus in chemistry, please contact our experts there, and they'll be able to have a bit of a discussion with you about the theme that you'd like to explore in your master's and PhD studies. But we also have to focus on biochemistry, and I'm going to ask Dr. Rensha van der Sluis to address us on that. She sits on the NWU's Potchefstroom campus. Rensha, thank you for availing yourself.
Thank you. Yes, I will be discussing firstly the honors program in biochemistry, and then on both the Mahikeng and the Potch campus, and then elaborate on our focus area in terms of the masters and MD students.
All right, so let's start with that honors program in biochemistry. What is it all about?
So we have an honors program on both the Potchefstroom and the Mahikeng campus. They are not aligned between the two campuses. The reason for that is that we have different research focus areas. So if you do a honors on the Potchefstroom campus, you will specialize in specific techniques. And if you do an honors on the Mahikeng campus, then you will specialize in the techniques that they have there. So for our honors on the Potchefstroom campus, we have both theory modules as well as practical research project that you have to complete. So with regards to the theory modules, we have two main focus areas, which is metabolism and molecular genetics. So you will do theory modules in both of these specialization fields. And then when it comes to your research project, you will choose a research project that focuses in either one of these fields. And it will be about a 3-month research project that you have to complete individually.
When do you accept applications for the honors?
So the applications are open now until the 31st of October. We accept the applications and then we go through them on a merit basis. So you have to have biochemistry on the 2nd and 3rd year level, because we look at the average of the marks on the 2nd and 3rd year level. And then we rank the applications according to the marks or the average of the 2nd and 3rd year marks. We only have space for 15 students on the Potchefstroom campus. So then we will select the 15 best students for the honors program.
So in other words, they have to act now, as it were, and apply because of the limited space available both in Potchefstroom and on the Mahikeng campus.
Yes, please apply as soon as possible and have your marks ready, because last year we received over 100 applications and we could only take 15 students.
Wow, that's impressive. All right, so on the master's and the PhD level, how does it work there?
So we function within a focus area within the Department of Biochemistry. We have 4 main laboratories that you can work in to complete your master's or your PhD. The first one is the BOSS lab, which is the Biotransformation and Oxidative Stress Laboratory, which focuses on detoxification analysis and how to make your diet better so that you can feel better and detoxify food and chemicals better. Then we have the TB and HIV research group, which focuses on how to develop therapies for treatment of HIV and TB. Then we have the mitochondrial research group, which focuses on energy disorders, genetic disorders found within the mitochondria. And lastly, we have the molecular genetics group, which focuses on virology, mainly rotavirus research, as well as HIV research. And then we also have a human and animal genetics section within the molecular genetics laboratory, which mainly looks at genetic variation within humans as well as animals.
So I can think that by the time you consider doing your master's or your PhD, you already have an idea into which of those fields you'd like to specialize in. But you would know that the identification of a theme within these different fields, that also takes some doing and some discussion. What about your team? Are they available for people to engage with them before they consider application?
Yes, if you want to apply for a master's or PhD within our focus area, please contact the research director first. He will then have a discussion with you, find out what you're interested in, and he will then guide you to the relevant laboratory or research group that can then help you. You will then make an appointment with the lecturers within the research group, and they will then have a discussion with you to identify a project. Because you do need a project before you can apply for a master's or PhD with us. And there has to be funding available. We need to have lab space available. So you need to make an appointment to identify a project, a supervisor, before you can submit your application.
So I can only assume that you also have a limited number of students that you take into the master's program specifically?
We don't really have a limit in the sense that we have a set number. It depends on the funding that we have for each year, the capacity of the supervisor, how many students he or she can supervise. So yeah, there's no set limits for this specific year.
And can they apply now?
Yes, yes. The applications are open, so please first contact the research director and our focus area so that we can help you to identify a project and then you can apply.
Thank you so much. There you have it, ladies and gentlemen. That's what we focus on in the School for Physical and Chemical Sciences. Thank you to all the experts for your time. Apply now. Ladies and gentlemen, if we talk about excellence in the Faculty of Natural and Agricultural Sciences, then we have to talk about the focus area in chemical resource beneficiation. It's a field full of tremendous experts and incredible focal areas. We have here with us Professor Henning Krieg, and he'll tell us a little bit more about chemical resource beneficiation. Good day, Professor.
Thank you for the kind introduction. Yes, so as you said, it's an interesting field and it's definitely relevant both for our country and of course in the resource province that we are. So yes, definitely focused where we need to be.
Now, you've prepared something for us to tell us a little bit more about the postgraduate product offering within chemical resource beneficiation. You're welcome to share it with us.
Thank you very much. This is just the introductory slide, but so yes, the focus area for chemical resource beneficiation is an entity, as I said, hosted within the Northwest province and definitely focused on that. However, within the university, the entity fits into natural and agricultural sciences. And you will see on the one hand, we have the research entity, on the other hand, you have the physical and chemical sciences. So in terms of undergraduate studies, that is the right direction you would be taking, ending up with majoring in chemistry. And that will be your prerequisite when you want to do research in chemical resource beneficiation. You will also see there towards the back that we also have collaboration with the engineers and specifically the chemical and mineral engineers. And that does make sense because mineral engineering and resources is very similar. In terms of the relevance, you can see that Minister Mantashe said we need to grow the economy, and one of those is actually by beneficiation, which is exactly what we're doing. You can also see on this graph here that we have a lot of the reserves of resources in South Africa, and we need to do something with them. And therefore, you will see in the mineral policy promotion that we need to beneficiate. We need to do and add value to that. And you can see in our logo, that's exactly what we do. We bring in some resources, we develop processes, hopefully without any emissions, and finally, we produce a product that adds value that we can sell. So within our entity, there are 5 research groups. We do some applied molecular modeling, we do atmospheric chemistry, catalysis and synthesis, electrochemistry, and finally, hydrometallogy, all looking at various aspects of resources and how they can be beneficiated. However, in addition, we also have support services that do the analytical work required for this beneficiation and determination of the processes. So we have a laboratory for applied molecular modeling, laboratory for analytical services, and a laboratory for electron microscopy. So if I might just quickly take you through the 5 research groups and the 3 support groups. The first one is the applied molecular modeling. So they use computers to see how molecules and atoms behave so that you can predict how you can best process them. So this is very fundamental theoretical work. Using the student will be sitting at the computer and using models to find information, even physical properties of these materials. Then our next group is our atmospheric chemistry. I don't need to say a lot. Obviously, environment and pollution is quite an important area in our field. And Prof. Peter van Zyl has been leading this group and is leading this group where they develop processes and monitoring. Here you can see a monitoring station on the right-hand side, where they are monitoring various gases and studying effects of pollution in the atmosphere. The next group that we have is our catalysis and synthesis. This is your more traditional, what you would call organic chemistry. This is like real fundamental chemistry work. They're developing very interesting surfactants that can be used again to extract certain minerals. They develop catalysts, and they do really exciting stuff and research under the leadership of Professor Vosloo. Then our 4th group, they are doing electrochemistry. Electrochemistry is where really you play around with the oxidation states of these metals. And that's, of course, important, again, if you want to purify or beneficiate them, i.e. adding value to them. So this group, they really do fundamental work on electroplating and understanding. And you can also see they actually also do some molecular modeling, the DFT modeling right at the bottom. And this group then is led by Professor Kobus Kriek. The last group that we are working on is hydrometallogy, which is using an aqueous environment to purify and refine metals. So this is spot on again within the whole resource beneficiation field, using different techniques, membrane-based, as well as other techniques to try and purify, add value to our resource base. So instead of just selling resources, we can sell value-added products. Now, when it comes to our support services, the first one is, again, referring to the applied molecular modeling. In this case, it's the laboratory, and they do a lot of training. They help with method development for other groups. They have software, they work with software, they support other groups in terms of helping them in the specific fields they are busy with. Then the next group is, again, very traditionally what you would call analytical chemistry. We have extremely expensive, highly equipped facilities state-of-the-art analysis. And this is, of course, used by all the research groups to determine, are you actually doing what you think you're doing? So analytical chemistry is extremely important. And that obviously is one of the research directions that, although it's a support group, there are people doing research in this field as well within the CRB. Finally, very visually, our laboratory for electron microscopy, and they have scanning as well as transmission electron microscope. And very exciting, we have just received funding to buy an atomic force microscope. So we will expand our abilities. And these are just very expensive ways of showing very small things in high resolution and definition, as you can see from, for example, here is a leaf, or those are membranes, very highly magnified, high resolution. So that's about the research groups and the support groups and the fields of study that you would be doing in a CRB. As I said previously, all of them based on undergraduate chemistry as a major. So when you look at the qualifications that you can do within the CRB, there are two possibilities. Well, firstly, you do have to do a master's before you do a PhD or a doctorate degree. We've got two qualifications. The master's is an MSc in chemistry. There you see again the strong link to the chemistry background. It usually takes about 1 to 2 years in the form of a dissertation, and it's 180 credits, while the PhD is significantly longer, 2 to 4 years. You there have to write a thesis at the end of the research, and it is 360 credits. Important to note that both these qualifications are research only. So there's not a theory component, there's not an exam, there's really the research written up in a dissertation or thesis, which then gets examined, and then you pass and or not, but hopefully usually the students do pass. This can be done full-time or part-time, but as I said, this is usually laboratory-based. It is practical work. So full-time people obviously would do it in the laboratories on our facilities, on our campuses. However, part-time often obviously have to work. So there it is possible to do it part-time, but we do require that you have some facilities where you're working to actually do the research work. But we can further discuss what other prerequisites would be required if you would want to study part-time. Applications, we're actually quite flexible there. We accept them throughout the year. Usually, of course, most projects start in the beginning of the year, but we get throughout the year people asking, can they come and study with us? Then we take that to the various groups, and the groups then decide, do they have funding for this project? Can they support the student? Is there a suitable project? And only then do we take a student in for a master's or a PhD program. So if you do have any further questions, the best person to contact would be Ms. Estelle Stoppel. There you have her details, or of course, you could also contact me if further information is required. Thank you.
Professor Henning Krieg from Chemical Resource Beneficiation, thank you so much for that wonderfully detailed presentation. I think we've got it all covered. If they are interested, if there are any people interested in this line of work, you're more than welcome to contact the focus area and have a discussion about how that master's or PhD degree might be coming your way. Ladies and gentlemen, good day and welcome to this discussion of the focus area for material science and in innovation and modeling. Material science, innovation and modeling. Wonderful to have you here, and we look forward to sharing some insights on what's happening in the focus area. And just as a bit of an add-on, we are also going to discuss the Center of Applied Radiation and Technology. We have two experts in the field here with us today. They are actually on our Zoom platform, and we appreciate their time. Two professors, Professor Esther Fayemi and Professor Michael Esiefarienre, and we'll be talking to them about the postgraduate offering within their field and within their focus area. But first I'm going to ask Prof. Esther to tell us a little bit more about the focus area and what exactly they keep themselves busy with. Good day, Professor Esther. Thank you for being here.
Good day. Thank you for having me here. Yeah, from the name MAZIM, and like you rightly said, it is a center of material science, innovation, and modeling. The center focuses on areas whereby we have physics, chemistry, mathematics, and computer science, also the Center of Applied Radiation Science and Technology. It is a kind of disciplinary and interdisciplinary center. And there we have about 30 researchers that carries out research in 3 main research areas. And in the history of the focus area, we've had quite a good number of M&D, that is master's and doctoral students, that have graduated with distinctions and with good comments on their research work. And the center also is centered on taking care of students in the area of funding, and then also taking care of researchers in the area of their development. Yeah, thank you.
That's wonderful, Professor, and it's a nice focus both on the subject field, but then also on the support. Prof. Michael, I would like to ask you a little bit about your areas of specialization. Tell us a little bit more.
I'm actually a specialist in the field of computer science, with may focus on software engineering and process mining. What we do basically is to conduct research in innovations with intensive practical outlook. So we actually do networking, both next generation networks, software defined networks. We are also into data mining, but most importantly, we do cloud computing, databases for M&Ds, which is masters and PhDs. So for me specifically, my area of research is in software engineering with emphasis in process management and risk management. Thank you.
Thank you, Prof. Yeah, those are the MSCs, the master degrees in computer science, and then also the PhD. But Prof. Michael, within the focus area, you also offer an MSc in mathematics and an MSc in applied mathematics. Tell us a little bit more about those two qualifications.
Yeah, we offer M&D degrees in mathematics and applied mathematics. Usually mathematics in terms of dynamic systems, and then in applied mathematics, what we do is to apply the concept of mathematics to modeling in specific areas that is chosen. So most of the difference is that one has to do with proofs and theorems, while the other has to do with the application of the proofs and theorems to specific areas, practical areas that are of importance to the society.
Professor, I like the idea of the difference in focus, because I think, you know, it really allows for an exploration within the field of mathematics. And then, of course, when you get to the PhD level, a contribution to the body of knowledge. I can only think of new models, that really contribute to our understanding of what applied mathematics is all about.
That's correct. In applied mathematics, what we usually do is modeling of dynamic systems, and applying this modeling to, it's not just doing the modeling, but the application of the modeling to a given area of interest. So, but if you want to study, applied mathematics, it means you must have learned the concept. And then what we do at that level is to apply the concept to modeling and taking the results of the modeling to its application. So you find out that most times the applied mathematicians are more of, performing modeling, and then the mathematics itself is proofs of concept, and then, generating new models and generating new theorems. And that is actually the difference. One focus on theorems, disproving and generating new theorems and models, while the other has to do with application of these models to vivid areas of human endeavors.
Thank you, Prof. Michael. Fascinating. Prof. Esther, but within the focus area, you also focus on chemistry and physics, right?
Okay, I'll start with chemistry. Like also, I think I need to bring you back home a little bit. For my expertise, I base on analytical chemistry and electrochemistry, for example, and we do apply this electrochemistry in different areas by fabricating a nanosensor using nanomaterials or using nanofibers. And that also takes us to a beautiful techniques known as electrospinning techniques. So we apply these materials in the detection of adulterants in food or contaminants in the environment, such as pesticide, organochlorine pesticide also, which is being used by farmers. And not only that, biological molecules, which can cause a lot of kind of effect or side effects on human's health. And basically we work on the neurotransmitters. And these are things that centers on the neurons, which also deals with your focus and how calm you are. And you can see my background, which is a fruits kind of background. So it shows we also try to look at ascorbic acid concentration on some of those food samples. And in chemistry as well, we have area of research whereby colleagues deals with my production of nanodrugs. And these are being a wonderful research indeed, and which is conducted by Prof. Lebo Katata, and also assisted by the HOD of the department, which is Dr. Simbili. We also have other colleagues in the area of modeling, and then that is computation chemists. We have Dr. Susibo, and we have good colleagues also doing great work in the Department of Chemistry based on nanomaterial synthesis, thermodynamics, like physical properties of solutions. That is Prof. Indra. And we also have catalysis, people dealing with catalysis in the chemistry department. We as well have photocatalysis group, and also area of crystal preparation of crystals, synthesis of crystals, characterization of crystals, and that we have Prof. Damian. Then when we move to the physics department, we have people that also have good research outputs in the area of sensor, solar radiation, monitoring physical processes, control and monitoring of radiation in household materials. Then we have Prof. Mawire and other colleagues that are in that area of studies. Thank you.
Professor, it sounds like an incredibly brilliant and dynamic team, really a great assembly of people. Prof, tell us a little bit more about the details and the logistics when it comes to the master's and the PhD programs, such as the mode of delivery and the site of delivery and application dates and so on.
I would say that for master's and doctoral students, we do have, let me just say, from the stream of honors, you have students that get interested in these areas of study and decided to apply. How I really want to go into material science, I want to go into computation, I want to go into nano drugs, and you see them move as in their interest, then get their application into the good school system. And at the end of the day, some of them are admitted. And afterward, we got a message that so and so has applied under your study. And then we love to have masters in this area. And this other one also, we love to have doctoral certificates in this area. So for such students, we absorb them into the system with the help of the head of the department, and also take them through how to get their proposal approved by the school, and also ethical clearance before conducting the experiment, and take them through the whole process. For masters, it's just 2 years program. For doctoral students, maximum of 3 years program. But in case there's any kind of delay, perhaps because of COVID or whatever, some student can have a sleepover, maybe 2 years plus or 3 years plus.
Thank you, Professor. Prof. Michael, I'd like to ask you, if someone is interested in studies within your field, should they contact you? Should they apply and then contact you? How do you go about in communicating with them regarding the focus of their studies or the theme that they'd like to explore?
Thank you very much. Admissions actually depends on the student itself, where the student is located. If you are located within the university environment and within it's possible you contact the supervisor or make an inquiry, go to NW profile and look at the lecturers that are specialized in that area. That is if you want to be more specific, but generally, if you want to apply for a master's or a PhD in computer science or mathematics, all you need to do is to go to the NWU website. There's a link for application. You fill in the form and attach the necessary documents and you submit. Usually the forms will get to the department. The department will make the selection based on qualification. It is when you are admitted, for example, you are not even based in South Africa, you are based in another country, you just do the application, the forms get to the department. The department will itself look at the forms and further ask for a proposal or an area of interest by communicating to you. Your application has got to us. We want you to submit a mini proposal of your interest, or these are the interest areas we conduct research. Which of these are you interested? The conversation then goes on. And then as a department, we look at the students that have applied, and assign them to specific supervisors, professors and doctors that are major in those fields. That is one way admission can come. If a student specifically, consult a professor or a doctor for supervision, and the area is within that professor's research focus, it's also possible to directly admit that student, but the student has to go through the process, because in the admission form, there is a place where you have to put the name of a supervisor that will supervise that research, because we at NWU, we ensure that for every master's and PhD student that is actually admitted has a supervisor on ground that will do the supervision. So if you know a supervisor that is majoring in that area or has majored in that area, there's no problem. You can put the supervisor's name and it will be processed. But for every student, the formal procedure is you apply through getting the manual form if you are close to the university, or you just go online and click the link for application. Then you apply and attach the necessary documents. You know, we take students from NWU, from honors, for masters, and we can take any other graduates from any part of the world as far as you have the necessary qualification. Because if you did not study in South Africa, one thing foreign students should know, they have to get their certificates through SAQA, you know, converted to South Africa standard. And if the person is qualified, the SAQA certificate has to be attached to the application, because there's no way we can actually assess foreign qualification if the SAQA is not attached. And that is the issue we usually have from foreign students. So I want to also advise that if you are interested in application as a foreign student, you just go to the link. First of all, get your certificate evaluated through SAQA. And then if it is equivalent to a honors, you know, in South Africa perspective, then the person is eligible to do a master's degree. So we admit students who had background in computer science for computer science, background in mathematics for mathematics. Then we can also admit students for mathematics that wants to study computer science, and student that studies computer science at specific, you know, fields to do masters or PhD in mathematics. So these two fields are interwoven, you know, at a higher level, for example, a PhD or master's. So any of them can apply in any of these fields. You know, you can apply directly if you don't know a specific lecturer in that department. The funds will get to the department. The student will be communicated of area of interest. And then if the area of interest is within that field, you know, we will accept that candidate. Thank you.
Thank you, Professor, and thanks for explaining that to us. Professor Esther, Professor Michael, before we say goodbye, just one last quick word from you on the Center of Applied Radiation and Technology. Professor, tell us a little bit more about the center.
Like we rightly said, CAST offers innovation research, which is aligned to the need of diversity, expand, sustain, and maintain high-quality nuclear skills across the breadth of South African research and also industrial formations. So they basically deal with research that deals with nuclear radiation. So Prof. Michael, we had more to the information.
Yeah, thank you very much, Prof. Usually in CAST, what we are interested in is you know, specific research that has to do with industrial formation, you know, and here indigenous technology, you know, indigenous South African technology is actually the focus. How do we enhance indigenous skills and create indigenous technology? You know, that is mostly the area of CAST in terms of nuclear science and radiation.
Professors, thank you to the both of you. We really appreciate your time and effort. And to those of you watching this and interested in their field of study, apply now. We're looking forward to receiving your online applications for the focus area for material science innovation and modeling. Thank you.